Imagine traveling farther than any human being has ever gone. You leave Earth behind, pass the moon in just a few days, and watch the planets slowly disappear into the darkness. As the years turn into decades, even the sun becomes nothing more than an unusually bright star among billions of others. Out there,
When most people picture the solar system, they imagine the sun surrounded by 8 planets, along with moons, asteroids, and distant icy worlds. It seems like a complete picture, but it leaves out something enormous. Our solar system doesn't simply drift through empty space. Instead, everything we know exists inside a gigantic, invisible bubble created by the sun itself. This bubble stretches for billions of kilometers in every direction and acts as a protective shield against the harsh environment of our galaxy. Although we cannot see it with our eyes, it constantly surrounds us, protecting every planet that orbits our star. The reason this bubble exists is because the sun is far more active than it appears. Every second, it releases a continuous stream of electrically charged particles from its outer atmosphere. This stream, known as the solar wind, races outward at hundreds of kilometers per second in every direction. As these particles travel through space, they carry the sun's magnetic field with them, gradually inflating an enormous magnetic bubble around the entire solar system. Scientists call this invisible shield the heliosphere. It is so large that even light takes many hours to travel across it, making it one of the biggest structures created by our sun. The heliosphere is much more than an invisible border. It serves as Earth's first line of defense against the dangerous environment of the Milky Way. Across our galaxy, exploding stars, black holes, and other powerful cosmic events launch high-energy particles known as cosmic rays. These particles travel through interstellar space at incredible speeds and carry enough energy to damage electronics, interfere with spacecraft, and expose astronauts to dangerous levels of radiation. Fortunately, the heliosphere acts like a giant magnetic shield, deflecting many of these charged particles before they can reach.
For more than 3 decades, the Voyager spacecraft continued their lonely journey away from the sun. There were no planets left to photograph, no moons to fly past, and no dramatic close encounters waiting ahead. Yet their mission had quietly transformed into something even more extraordinary. Every kilometer they traveled carried them deeper into a region that no human-made object had ever explored. Scientists on Earth watched their data carefully, knowing that one day these aging spacecraft would reach the invisible boundary separating our solar system from the vast ocean of interstellar space. No one knew exactly when that moment would arrive, or what the spacecraft would encounter when it did. As Voyager 1 moved farther into the darkness, its instruments began recording subtle but important changes. The stream of charged particles flowing outward from the sun was becoming weaker than ever before. At the same time, detectors were picking up increasing numbers of high-energy particles arriving from outside our solar system. It was as though the spacecraft was slowly leaving one environment and entering another. Then, in 2012, after traveling for nearly 35 years and covering billions of kilometers, Voyager 1 crossed a boundary that humanity had never reached before. Without fireworks or a dramatic explosion, it quietly entered interstellar space. For the first time in history, a spacecraft built by humans had traveled beyond the protective bubble created by our sun. The crossing itself was invisible. There was no giant wall floating in space, no glowing barrier, and no physical gate marking the end. Even after crossing the heliopause, the Voyager spacecraft had not actually left the solar system in the way many people imagine. This is one of the biggest misconceptions about their incredible journey. Crossing the heliopause simply means they have traveled beyond the sun's magnetic bubble, not beyond the sun's gravitational reach. Gravity is far more powerful over long distances than the solar wind. While the heliosphere marks the end of the sun's magnetic influence, the sun's gravity stretches much farther into space, extending across a vast region filled with icy objects known as the Oort Cloud. This enormous cloud is believed to surround the solar system like a giant shell and may contain trillions of frozen bodies left over from the formation of the planets more than 4.5 billion years ago. It begins thousands of times farther from the sun than Pluto and may extend nearly halfway to the nearest star. By that definition, Voyager 1 and Voyager 2 have only begun the next chapter of their journey.
They have stepped beyond the front gate, but they are still traveling through the sun's immense gravitational neighborhood. The scale of these distances is almost impossible for the human mind to comprehend. If the distance between the Earth and the sun were reduced to just 1 meter, Pluto would still be nearly 40 meters away. The inner edge of the Oort Cloud would lie several kilometers farther, while the nearest star would be dozens of kilometers beyond that. Even traveling at speeds of more than 60,000 kilometers per hour, Voyager 1 will need hundreds of years just to approach the inner region of the Oort Cloud. Crossing the cloud itself could take tens of thousands of years. Long before that happens, every scientific instrument aboard the spacecraft will have fallen silent. Keeping the Voyagers alive has become one of NASA's greatest engineering challenges. Unlike satellites orbiting Earth, these spacecraft cannot rely on solar panels because sunlight at their current distance is far too weak to generate useful electricity. Instead, they are powered by radioisotope thermoelectric generators, which produce electricity from the natural decay of plutonium. These remarkable power sources have allowed the spacecraft to operate for nearly half a century, but they slowly lose power every year. To conserve energy, mission engineers have been shutting down instruments one by one, carefully